Hey everyone at home, welcome to today's lesson, which is on scientific notation. Um, it is not a new topic. It is for 8th grade, but you did learn this last year in 7th grade. You probably spent almost an entire week on scientific notation, and we're just going to do a quick review of pre-algebra and making sure that you guys remember the scientific notation. It will eventually tie into our exponent rules that we have been doing this past week. Remember, the exponent rules that we've learned are the MA problems, the DS problems, and the PM problems. So MA stood for the multiplication problems, two things multiplied by each other. DS stood for the division problems. A lot of times you'd see it as a fraction, but again, division problems. And PM problems were something raised to a power. Keep in mind, M stood for what to do with the coefficients, so multiply them. A stood for what to do with your exponents. Same as DS. First letter is coefficients, second letter is exponents, so divide and subtract. And then same with PM. P stood for the coefficients, so power them up. And M stood for the exponents, which was to multiply your exponents. Okay, so the types of problems that we're going to see in this lesson eventually at the very end here are going to be the MA problems and the DS. They will come up. We're going to be multiplying some numbers in scientific notation as well as dividing some numbers in scientific notation. So keep those shortcuts in mind when we get to that. All right, first off, I kind of asked the class today is where would you use scientific notation? Like, what is it for? And the whole point of scientific notation is to take these really big numbers like that, or really, really small numbers like this number, and shorten them, because that is a lot of zeros. And there is a quicker way to write these. And that is what scientific notation is for. So this is how it's going to be written. It's going to always be some number, that's what C stands for, some number. The X here is the only time that we use a times. We use an X for times. Usually it's kind of frowned upon once we get older, because we'll use a dot or parentheses. But for some reason in scientific notation, they always want an X to represent times. And then it's always going to be times 10. And so the two things that are going to change here are the C. That C, you can see down below, it needs to be between 1 and 10. It can be 1, that's why it's equal to, but it can't be 10. It has to be less than 10 or greater than or equal to 1. Okay, so that will change based upon the number. So will the N. N represents some kind of integer. In other words, it could be positive, it could be negative, but it has to be a whole number. All right, so let's start off with these. The first step that I usually do is I either do it physically or in my head, cross out the zeros. Now, I know that the decimal place in this number is right there, because that's the spot where we don't write decimal places. And so I am looking at this number that's left, which is the number 12, and I need to make this in scientific notation. Well, right now, for that to be the first number, C, it has to be between 1 and 10. Well, it's not between 1 and 10, but I can make it between 1 and 10 by putting in a decimal. So I just added in a decimal there to make that number 1.2. Again, it's always going to be times 10. Now, to figure out the power or the exponent, most common mistake is that people think it's how many zeros, but it's not how many zeros. It's how many places we move the decimal place. So it would be the zeros plus that 2. And you can see here, I'll demonstrate 1, 2, 3, 4, 5, 6, 7, 8. There were 8 spaces in between the 2 decimal places. So we have 1.2 times 10 to the 8th, and that is that number in scientific notation. All right, let's try another one. I'm going to cross out the zeros. 52, again, not in scientific notation. I'm going to add in a decimal place. So 5.2 times 10. And if the decimal place was here, I know that there are 3 spaces there. There are 3 spaces there. There are 3 spaces there. and then there are 2 spaces there. So 3, 6, 9 plus 2 is 11. That would be your answer in scientific notation. All right, C. Again, cross out the zeros. We're going to make that 4.1 times 10. And there are 3 spaces here and 3 spaces there to make that to the 6th power. Now, realistically, this number here, 670, would never be written in scientific notation. And honestly, probably none of them would be, because it's more for numbers like this. But this would kind of take us a while to do. We could do it, but it would take us a lot longer. So in math class, we just shorten it to kind of understand the concept. Okay, so I'm going to cross off my 0, make 67 between 1 and 10, so 6.7 times 10 to the 1 to 2nd power. Again, I wouldn't write that in scientific notation because the whole idea of scientific notation is to shorten it. 670 is very short, so I actually made it longer in this case, and that's why I would never use scientific notation for that kind of number. All right, cross out the zeros here. We're going to put in a decimal place, so 2.04. I have to keep the 0 when it's right in the middle, and then again, count how many times you moved your decimal place. So 3 here, and 1 there. So 36 times 10 to the 7th power. All right, we're going to do another slide here of examples. These are different. These are really, really small numbers. Where this last one, they were big numbers. These are small numbers. Same concept, it just looks a tad bit different. I'm going to take out the zeros. I have 12. I'm going to make it 1.2. Now this, I don't have to add in another decimal place because they already gave us a decimal place. So again, it's always going to be times 10. How many places are between those 2 decimals? Well, there's 1, 2, 3, 4. But this is not a correct answer because this is a really small number. Decimals or fractions are created by negative exponents. So this is a negative exponent there. One way I remember this is if you guys would give me this amount of money, any amount on this page, I'd be really, really happy with you. Happy means positive exponent. If you guys gave me any of these amounts of money, I would not even accept it because it's so, so, so small. I would not be happy. I'd kind of roll my eyes at you. So that would be negative. You'd get a negative reaction. All right, so let's do G. Cross out the zeros. We have 52, so 5.2. How many spaces are there? 1, 2, 3. So it's going to be times 10 to the negative 3rd. H. We'd make a number here between 1 and 10, so 4.1 times 10 to the, only moved it once, so negative 1st. All right, I cross out the zeros. This would be 6.7 times 10. How many times did I move it? 1, 2, 3, 4, 5, so to the negative 5th. J, again, we can't take out the 0 in the middle, so we put 2.04. How many spaces are in between? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So times 10 to the negative 10th power. All right. Feel free to pause here if you'd like to try some on your own. And then I'll just put up the answers. All right, this is what you should have gotten. 1.5 times 10 to the 1, 2, 3, 4th power, but did you remember to put in a negative? All right, this one should have been 2.05 times 10 to the, this would have been 3, 6, 9, 10 to the 9th power, positive, big number. Next one would be 4.01 times 10 to the 1, 2, 3, 4, 5. But again, did you remember the negative? N is 6.8 times 10 to the negative 3rd. And this one was hiding here. Cross out the zeros. We just have the number 3 times 10 to the 5th power. Hopefully you did okay on those. because we are going to move on now to operations with them. Okay, so now that we kind of understand what it was, we've got a refresher, we're going to start adding and subtracting as well as multiplying and dividing. Okay, so let's start with adding and subtracting. In my opinion, this is the toughest operations to do. So here are the steps we're going to follow. Step one, we are going to make them, both numbers, when I say them, into standard form. So in other words, we're going to make them look like a normal number. Then we're going to add or subtract them. Important part is to line up your decimals. Then if they give you the problem in scientific notation, usually the rule is to answer in scientific notation. So step 3 is to change or convert your answer back to scientific notation. So those are the 3 steps that we're going to follow. And actually there is a mistake on this one. On number 2, these 2 numbers should be switched around, else I'll get a negative answer and I don't want that. Okay, so let's do 2 examples of adding and subtracting. First off, you have to identify what it's asking for. So it says find the sum. Sum means to add the 2 numbers. So I am doing 4.1 times 10 to the second plus 2.6 times 10 to the fourth. Okay, so I'm going to follow those steps. Reason being is that we are adding and subtracting. If you remember when I started this lesson, we talked about our shortcuts, the MA, the DS, and the PM problems. None of those dealt with, if you look up here at the operations, none of those dealt with adding or subtracting. There are no shortcuts on this. Okay, so again, I'm going to follow my rules of changing them both into normal numbers. Since this was a positive 2 exponent, I'm going to move it 1, 2 times. And I would fill in a 0, so that is the number 410. And I'm going to put the decimal place there because if you remember, step 2, I have to line up my decimals. It's really, really important. All right, so I'm going to do the same thing for the other number. I have to move it 4 times, so I'm going to move it once here, and then I have 3 more times to move it, so I'm going to have 3 zeros there. So that is the number 26,000. Again, it's very important to line up your decimal places. Again, since it said sum, I'm going to add those together, bring down my decimal. So that's 0, 1, 4, 6, and 2. That is the correct answer. But if they're giving us the problem in scientific notation, we should probably answer in scientific notation. So let's say what that actually is. So I would put in a decimal place to make it between 1 and 10. So 2.641 times 10 to the, how many times did I move it? 1, 2, 3 to the 4th power. Now usually this exponent should match the biggest exponent up there. Okay, now I say usually, I'd say like 95% of the time those 2 will match. All right, so again, I said there was kind of a typo in this problem. So the problem I wanted you to do, difference means to subtract. So I wanted you to take the big number here, 5.1 times 10 to the 5th, minus 3.4 times 10 to the 3rd. Okay, we're going to do the steps that I said earlier. So change them both to standard form, or a normal number. So on this one, I would move it once, but I have 4 more times to move it, so I would have 4 zeros. So 5, 1, 0, 0, 0, 0. Again, put a decimal place there. The next one, I need to move it 3 times, so there's 1. I'd have 2 more times, so 2 zeros, so that would be the number 3,400. And we're subtracting these 2. Now, I know it's been a long time since you've subtracted bigger numbers, so don't forget to borrow here. Bring down your decimal, 0 minus 0, 0. Another 0. I can't do 0 minus 4. I need to come and borrow all the way over from this 1. I'll make that a 0, make that a 10, borrow from that, make it a 9, and make this a 10. So 10 minus 4 is 6. 9 minus 3 is 6. Bring down your 0. Bring down your 5. This is the correct answer, but it's just in the wrong form. So let's put equals, and this would be 5.066 times 10 to the, how many times do we move it? 1, 2, 3, 4, 5. And that's our final answer. Again, you will see that it usually matches the bigger exponent. It's a good sign if it does. All right, in class right now we had our commercial break. So going back to our objectives to see what we've covered. We have covered how to change things into scientific notation. We have covered how to add and subtract numbers that are written in scientific notation. Now we're going to go to the multiply and divide. Those, however, were shortcuts that we have learned. We have learned the MA problems and the DS problems, and we can use those shortcuts on these problems. Okay, so let's do multiply first. Again, these are the MA problems, and they're going to very closely match what we've already done. We are going to multiply the coefficients. It says follow the laws of exponents on this. Since they all have a base of 10, we are going to keep the times 10, and then we are going to add, that's the second letter there, add our exponents. Okay, now this last one's the tricky one that people always forget. Everybody thinks it makes sense when we cover it, but then when it's homework time or quiz time, people forget to do this step, is to make sure your final answer is in scientific notation. Basically, you're checking to see if that number, the front number that we called C in our original definition, I'll go back to that just so you can see that. So the C, that number out front, has to be between 1 and 10. Okay, so we are checking to see if C is between 1 and 10. Okay, so that's our last step on this. All right, so first thing I would do is I would multiply my coefficients. Remember, these are MA problems. So multiply those two numbers out front. You could use a calculator for this. That would give us 7.5. All right, we always keep the times 10. And we add our exponents. So this would give us -1. Okay, step 3 says to check to make sure that first number is between 1 and 10. Well, 7.5 is between 1 and 10, so that would be our final answer. Now, I know in all of the other things that we've done with exponents, you have not been able to have a negative exponent. This is the one time you're allowed to have negative exponents in scientific notation. We actually want them to be negative rather than a fraction in these, because that's just the way that it's written. Okay, so let's try another one. We're going to do, again, MA problems here. So we're going to multiply our coefficients. 6 times 9 is 54. We're going to keep our bases times 10, and we are going to add our exponents. So 5 plus 7 would give us 12. Now this is the tricky one that I was talking about. Is this number between 1 and 10? Obviously 54 is not. So we're going to make it between 1 and 10 by putting it in a decimal place. But if I put it in a decimal place, I have to technically move it over one more time. And that means whenever we do that, we add a +1 because 54 is a big number. So we add one more, a +1 to our exponent to make this times 10 to the 13th. All right, let's try the last one here. Take your coefficients, multiply them. I'm going to get out my calculator. So we're going to do 5 times 7.5, which is 37.5. I'm going to keep my times 10. And then we add our exponents. -3 plus 8 would give me to the 5th power. Again, double check. Is that first number between 1 and 10? Obviously it's not. We're going to make it between 1 and 10. I moved it over one more time, so I have to add a +1 to our exponent to make that 6. So that would be our final answer. 3.75 times 10 to the 6th power. All right, so now we've done multiplying. Let's do dividing. It's going to be very similar. We are going to, this time, be following the DS rules. So we are going to divide the coefficients. And to kind of simplify that, what this says here, we're going to keep the base, so keep the times 10 part. They're all going to have that. And we're going to subtract the exponents. And last, we always want to double check to make sure that answer is in scientific notation. All right, so let's do 3 more problems here. Let's slide it down so you can see all 3. Okay, again, we're going to be following the DS rules. So we're going to divide coefficients, which would give us 3. We're going to keep the times 10, and we're going to subtract the exponents. Now be careful on this. The class today kind of got confused on the first one. When I subtract, I'm going to do top minus bottom. Okay, so I'm going to do -2 minus 6, which would give me -8. And that would be my answer on this first one. All right, let's do another one. We're going to divide our coefficients. 9 divided by 2 is 4.5. We're going to keep our bases, so times 10. And we're going to subtract our exponents. 11 minus 5, that would give us 6. Our first number is between 1 and 10, so we're good there. All right, last one for the day here. We're going to divide our coefficients. Again, please use a calculator to help you with this. So I have 6.5 divided by 4. That gives us 1.625. We keep our times 10. Be careful on the subtracting. We have -4 minus -6. And if I do same add opposite there, turn that into a giant plus. -4 plus 6 would be 2. Final answer there, because 1.625 is between 1 and 10. All right, hopefully this helps with your homework. Hope to see everybody on Monday. All right, bye.